All right, so on your own paper, this is lesson 5.5a, double angle formulas. And the first example is to solve in the interval from 0 to 2 pi. All right, and our equation is sine of 2x minus cosine of x equals 0. All right, so in all these equations you guys are going to solve, you do have to use a double angle formula, because we can't solve this equation if one of our angles is 2x and the other is x. So we are going to use a formula. Which one do you guys think we're going to use? Okay, so we have sine of 2x here. This one is sine of 2u. That's the one we're going to use. So we'll just take sine of 2x and we're going to rewrite it as 2 sine of x cosine of x. All right, and then bring everything else down. All right, that's all we need from the formulas for this problem. The rest of it is solving like we've done before. What would we do first here to solve this? We're going to factor out a common factor. What is it? Cosine of x. All right, what do we do now? Good, set each of them equal to 0. All right, so now we just need to, the cosine of x equals 0, we're good, that one's done. This sine one, we do need to solve for sine of x. And then we're going to need to figure out what angles have a cosine of 0 and what angles have a sine of 1/2. So for the cosine equaling 0, is that a hand trick problem or is that a unit circle problem? Unit circle problem. So it's going to be one of the quadrant or multiple quadrant angles. And then if we are using the unit circle to find a cosine of an angle, do we use the x or the y? The x. So we're looking for something on this unit circle that the x coordinate is 0. So what do y'all think? Very good. Okay, so that's 2 answers for x. Ooh. One thing I didn't talk about, bless you, if the directions are like this, do we need to do the plus 2 in pi? No, so we're good. We don't have to add anything to that. All right, so for the sine of x is 1/2. Can I get that from these points? No, so we have to go to the hand trick. All right, and then remember when we're doing this sine using the hand trick, we find the square root of the bottom over 2. So if we want our sine to be 1/2, how many bottom fingers do we need? 1 bottom finger. All right, so what angle is that? Pi over 6. And you guys may not need me to go through all that every time, but if there's one person who's like still a little confused, I want to get it together. All right, now I put a comma, so obviously there's another one. So where else is the sign positive? Quadrant 2, good. And so what's pi over 6 in quadrant 2? Nice job. And that's it. Now, my first period had some time to work on their assignment. You guys are leaving early, so I'm not sure if you will. But some of the equations do get, the first parts get more complicated than that. So just hang in there. Just know you have to use the double angle formulas. So do that first if you can, and then just use as much algebra as you can to get it down. Okay, for example 2, the directions are to use a double angle formula to rewrite. All right, and our expression is the quantity cosine of x plus sine of x times the quantity cosine of x minus sine of x. Now, if we look at the double angle formulas, do any of those look like that? No. So what can we do? Yeah, let's go ahead and distribute. So because of the way this one is written, we can do the shortcut. If you don't notice that, it's fine. If you multiply it all out, it's still going to work. But the outside and inside factors will cancel out, and we're just left with cosine times cosine, or cosine squared, and then sine times negative sine is negative sine squared. All right, so that does look like one of them. It looks like one of your cosine formulas. So I would say that that is cosine of 2x. All right, you all okay? Okay, we're gonna do one more. It is kind of long. So on example 3, we're given that the cotangent of u is negative 6. And pi over 2 is less than u is less than pi. We're going to find sine of 2u, cosine of 2u, and tangent of 2u. All right. So to find those by using the formulas, which we have to find the sine of 2u, we need to know the sine and the cosine. To find the cosine of 2u, we could use one of these and only know one of those. But to find the tangent, we need to know the tangent of u. So we're going to draw a triangle. What quadrant is this triangle going to be in? 2. So if it's telling you u is between pi over 2 and pi, that is just a different way of telling you that u is in quadrant 2. All right, so I'm just going to draw quadrant 2. And then draw an angle out of the origin and label it u. All right, we are going to need to know sine of u, cosine of u, and tangent of u. We know the cotangent. So what do you guys think the tangent is? Good job. Okay, so I'm going to use the tangent to label my legs of my triangle, the opposite over the adjacent. All right, what do y'all think about the hypotenuse? square root of 37. Okay, so now I can find sine of u and cosine of u. Now, I want you guys to make a note that we are not going to simplify the radicals. We can, but it's going to make it easier if we don't. So don't simplify. So if you guys look at the formulas, they're either the sine or cosine are being squared or multiplied by each other, and that's going to take care of any radical in the denominator. So just to make it easier on ourselves, we're going to leave square root of 37 in the denominator. So the sine, is the sine going to be positive or negative? Positive, so 1 over the square root of 37, and just leave it like that. What about the cosine? Is it going to be positive or negative? Negative 6 over the square root of 37. Okay. So now we have everything we need to find these three things. All right, so to find the sine of 2u, I'm just going to straight up just write the formula. 2 sine of u, cosine of u. All right, then in the place of sine of u, I'm going to put in 1 over the square root of 37. And then for cosine of u, I'm going to put in negative 6 over the square root of 37. All right, then I'm just going to multiply. So if you need to, write 2 as 2 over 1 to help you not make a mistake. Multiplying fractions, you can do that. But we're just going to multiply the numerators together and get negative 12. And multiply the denominators. What are we going to get when we multiply the denominators? 37. And that's it. That's the sine of 2u. So the sine of 2u is the sine of the angle that's twice as large as u. So it's double u. All right, any question? Okay, well, let's find the cosine of 2u. Now cosine, there are 3 equations for cosine of 2u. Only one of these is on the formula sheet for the challenge exam, and it's the first one. But you can use any of them. I'm going to go ahead and use the first one, but later, like when you're solving an equation, if it makes it easier for you to use this one or this one, please do that. Don't worry about always using the first one. But here, we can choose to use the first one. So we're going to do cosine squared of x of u, just kidding, minus sine squared of u. All right, and then just plug it in. Whatever we're plugging in, we make sure that we square it. All right, you guys finish this one on your own, please. Okay, and we have one more to find. It's the tangent of 2u. All right, so I'm just going to write down my formula. And then we know the tangent of u is negative 1/6, so So I'm just going to plug that in for tangent of u. So 2 times negative 1/6 you can write two ways. You can write it as negative 2/6 if you want to. It works out fine either way. Or you can reduce that and write it as negative 1/3. It doesn't matter to me. We're going to fix it all in a second. All right, and then negative 1/6 squared is 1/36. Okay, so with this tangent, we always seem to have fractions and fractions. So what can we multiply by to get rid of that? 36, good. All right, so it looks like we get negative 1/12 over 36 minus 1. Or negative 12 over 35. There it is. All right. What questions do you guys have on the double angle formula? Good? Okay. So your assignment is out of the book today.